Hello, and we're in my house today. Got a bit of a problem with our central heating system, which is not working. Now, when you get a problem with your central heating or your hot water, your first port of call is probably to get hold of a plumber. Well, in actual fact, a lot of the problems with your central heating can actually be on the electrical side, which unless a plumber is qualified to do, they shouldn't be anywhere near it. Now, obviously, you know, when you've got a problem with your heating, there's no way of knowing whether it's on the water side, the boiler, or the electrical side. But in my experience, it's 9 times out of 10 the electrical side that goes wrong in the central heating systems. Now, we've got a Y-plan system. There's an S-plan system which has 2 valves, one for the hot water, one for the central heating. We're on a Y-plan, which is 1 valve which controls both, and I'll just show you exactly what I mean by that. Okay, so how does your central heating system actually hang together? Well, let's draw a nice simple diagram. So you'll have your boiler, and in our case we're going to have the pump within the boiler, just for simplicity. And out of the boiler comes some pipe work which will feed your tank, which is probably in your airing cupboard or something like that. There'll be a coil of pipe work going through and then come out the top, and we'll just connect that up in a second. And also at the top somewhere there'll be some pipe work going to feed your hot water taps. In the system there will be your 3-way valve, which is what we're talking about today, and that will be also connected to the boiler, and hot water will be connected into there. There probably would be letters on the valve as well, something like that. And on the other side, that's what goes to your central heating system, which isn't working at our house. There we go. I'm not going to draw in all the return pipe work, that'll just make it really complicated. So in a Y-plan system, what you'll have is a 3-way valve inside here. Now, the default position for it is it actually sits there. Now that's when there's no power going to the electric motor that drives this valve. That's where the default is. That's why when there's no power going to this motor, the fault that you'll probably see is your central heating system just will not work, and it's for this reason, is the valve is actually in that position. When there's no power going to the motor, or the motor isn't working. Now the motor inside here, the motor that's sitting on top, okay, has a spring which is always trying to bring it back to its default position, which is here. But the motor is more powerful than the spring, so when it actually gets power, it's actually powerful enough to bring this valve across and overpower the tension of the spring. So the other 2 positions this valve can be in is all the way over here, in which case you're only driving your radiators and your central heating, or the other position it can be in is in the middle, whereby you're getting hot water going to your taps and to your central heating as well, because the water flow can go in all directions. It's this position that I've currently got my motor in manually, and you'll see the little lever that moves around. I'll show it in the video, it'll be shown in a moment, but I've manually put it into this position so that the hot water is actually feeding both. Now obviously that's not ideal, that's not really energy efficient whatsoever, that's only a temporary measure when this system doesn't work. So later in the video you'll see this lever. If this happens that your central heating doesn't work, you can try this with the lever on the valve on the motor to at least get some sort of heating working. It doesn't always work. Sometimes the lever doesn't click into its manual position, but it's worth a try while you're waiting for someone to come in and fix. So what is actually going on inside here? Right, let's have a look, shall we? Move that out of the way. So, close-up view of that valve is basically this. So as I say, you've got that got that off your hot water that's going to your central heating, and this is going down to your boiler. So like I say, when there's no power going to this, the default position is the valve is here. Okay, and when your central heating, your control panel, if you ask for hot water, if the thermostat on the tank says that it's too cold or it's not reached the temperature that you set the thermostat to, it'll start the boiler going, heating up the water as well. Okay, so the other two positions this can be in is, as I say, can be over here. It can actually sit there, and basically what happens is that the motor will turn, it will go across here, and then will stop. Now the motor will still have power to it at this point, and it will be constant power. The moment the power is stopped, it'll start going back in that direction. Alright, the third position is right here in the middle. There's some clever electronics in here, which I won't go through at the moment, which cause the motor to stall in this position. The motor is designed to stall if it gets DC current coming through, and this motor will actually send DC current to this. I'm not going to go through how it does it, it just does. And that stalls the motor in this position, and then you've got hot water going to your taps and to your central heating. Now obviously you've got an electric motor. In these two positions, this is what will cause the motor to potentially burn out, especially this position, because effectively you're stalling the motor. And if it's held in that position for any length of time, the likelihood is the motor is going to fail at some point. That's the disadvantage of these systems, unfortunately. So that's why I'm saying in the video that the mechanical parts of this valve very rarely go wrong, and I'm sure plumbers out there will testify to that fact. What can go wrong, and what goes wrong more often than any other time, is this motor inside this housing up here, because it's been asked to do things that motors really aren't designed to do for any length of time, which is why, you know, I could get called out to these, you know, several times a year to get these fixed. If the householder calls an electrician out, which is why I've said 9 times out of 10, if something goes wrong with your central heating system, the first person you call is a plumber. Well, I'm hoping this video will show that that's not always the case that's necessary. Sometimes it's actually an electrician who will be able to fix this problem. So let's go back to the video and show how this problem has actually occurred at my house and how we go about fixing it. So let's have a look at the system we have here at the moment. At the moment what we've got is we have hot water, but we have no control over the central heating, and I'll show you what we've done to manually get that to work at the moment. So here we are, here's the tank, and we've got the thermostat down there for the tank. Got all the pipe work heading up there. Here's the three-way valve, which shows it's a Y-plan system. The pipe's heading off down there, pipe's heading off down there, and we've got controls over there for the main boiler, which is in our workshop. And this is the electric motor, and that's the control box, which at the moment goes downstairs to the control panel. And then we've got wiring up here. As you can see over there, the further one is the fused spur, which we've currently got off, which controls everything, and also I've got it off at the board at the MCB. The switch next to it isn't used anymore. So currently this valve is stuck. So, and I forced it to be stuck by the, oh, if I can just get this camera around, see that lever? That lever has been put into a position where it won't move. Normally that lever will move into different positions depending on what the control box is demanding from the system. And from there, and the thermostat that's downstairs in the hallway. And all that goes through this control box down there, and I've just, as you say, seen the diagram and explanation of how this all works. So when this valve sticks, as I have done now, and I've deliberately done that so we can get hot water to the central heating system, basically the hot water is coming through this pipe, and this pipe all the time. Now that's not an ideal situation, because in order to get that to work I have to run the hot taps in order to get the pump to work downstairs, because the pump is part of the boiler, in order to get all this system to work properly. Now what goes wrong most of the time is not the mechanical parts that are in here. This doesn't normally go wrong, and I'm sure any plumbers out there that are watching this video will testify to that fact. This very rarely goes wrong. What goes wrong more often is what's in here, and it's the electric motor. That, and that's because this motor is being controlled in a way that really isn't really good for this motor. In fact, effectively it is put into a stalled state, and obviously an electric motor like this won't like that for very long. In fact, this is the third motor I've had to replace in this system in the last 2 years. Now that's normally what will happen if you've got a problem with your hot water and your central heating, and the central heating suddenly doesn't work. You've got a system like this, 9 times out of 10 it'll be what's gone wrong in here, not the valve that's here. So it's an electrician's problem, not a plumber's problem, although a plumber will replace these, although realistically if the plumber's not certified to do any electrical work, he shouldn't be doing it. It should be an electrician's job. However, as I mentioned earlier, there is no way that a householder will know whether this is an electrical problem, a water problem, or a problem with the boiler. There is actually no way of knowing. However, a quick call to an electrician, possibly saying what the problem is, may well indicate that the problem is somewhere with the electrical part of the system, be it the motor or be it all the wiring that's in there. It could be anywhere. So anyway, let's get this lid off and I will show you what we can do to get this up and working again. So here we are with the cover off. As you can see that I've actually done this before. You can see the older Wago connectors on there, actually with all this stuff going into it. Now we have to undo this screw, and there's one on the other side that actually lifts this off this plate. Now there's not going to be no water escape at all when we're doing this, okay? It's not a problem. So we're just going to take this off, disconnect it from here, and then we can do the work we need to do with it. Okay, so here we are. The motor disconnected, so you can see how I've done the Wago. So you've got one of these red cables being connected into the blue wire here, and the other red one is actually going around. Ooh, there it goes. It's going into that bottom bit there. So the red wire on the right side is the new one. In this case it's orange wire. The orange wire on the right side is going down to that green block. The one on the left is heading to the Wago, and the blue wire. So we're going to replace that old Wago, one of the newer ones. We're going to cut those two things off there and re-strip them, and then we'll go on to how we disconnect that motor and put the new one on. Right, it is quite a fiddly thing to get this motor out, but what you've got a screw there, you have a screw there and then a lug there, and the lug fits underneath that motor arm there, that one there where my thumb is. Now if you can't get that lug out from underneath that tab, you're going to have to bend it with a set of pliers and then bend it back into place when you've finished. I've had to bend it because it won't come out. You may have other types of motors that won't have this quite a thicker block, and it'll actually twist and then come out, but in my case it doesn't do that, so we've had to just bend that lug slightly, which I'll bend back into place when we've got it. And you have to take it out before we can take this red wire out, because you don't have the space. So let's get that new motor in place, and then we can go from there. Right, so it's mounted again. One thing that'll help you remount it, you see that lever, if you put it into that fixed position, then that fixes the motor and all the gearing into the right place, so it slots back down into there. Can you see that? And it just makes it nice and easy to get in. Now, I'm going to show you something. There's a lot of resistance on that lever for this motor, which shows that it's working. When I did it with this one, nothing happened. So I think that's showing, I believe, that that motor had died. But we won't know until we get the power on. So let's do that. So yeah, so that's all working. Got the power back on. Hot water's kicked in straight away. Boiler's kicked up. Set the thermostat downstairs to about 20 degrees. Set the timers. Set the control panel to central heating. And yeah, it's all working, no problem at all. So there you go. So central heating and heating problems aren't always the realm of the plumber. A lot of the time they're actually the realms of the electrician. So just bear that in mind when your systems go wrong. It may be that it's the electric side of it that's gone wrong, not the water side. It is very difficult to diagnose, and I appreciate it's difficult to know which tradesperson to bring in. It's not easy. So one thing I will say, this is not a DIY job. Do not attempt this at home. Get a qualified person in to come and get this sorted out. It is 240 volts. It will kill you if you don't do things right, and if you wire it up wrong, you might blow the whole central heating electrical system. Not a good idea really, and it'll be a very expensive thing to put right. How much would that cost? Well, the motor's not cheap. It's about 30 quid, and even though it only took about half an hour to do, you're very likely to have an electrician charge you the hour, so probably you're talking between 70 and 90 pounds to do that repair job. Okay? Actually, let me just correct myself. Well, I knew what the problem was before I started on that job, so an electrician coming in has got to diagnose it as well and find out whether it's one of their problems or not. So, you know, 70, 90 pounds minimum, I'll correct myself and say. So budget for it being a little bit more than that if a tradesperson has to come in and first diagnose what the problem is before they even start fixing it. Okay, just bear that in mind. Anyway, nice and short that one. I just thought I'd put that in, and we'll see you on the next one.